here we have a concave mirror. It has a center of curvature C, a focus F and a pole P. Now say hi to Mr. O. O for object, and this is shown with an upward arrow like this. Now Mr. O is interested in finding out his image in this concave mirror. Now when is the image formed? An image of a point is formed when two divergent rays from it meet at a point after reflection. Now Mr. O is made of many such points and each point has infinite rays diverging from it. But we'll just take the rays passing parallel to the principal axis, a ray passing through the focus, a ray passing through the center of curvature, and maybe a ray incident on the pole of the mirror. Again, out of all these, we mostly would require only two rays to find the image. Also, instead of analyzing all the points of the object, it's enough if we find the image of the uppermost and the lowermost point to find out the image of the total body. Now, Mr. O could be anywhere, between P and F, between F and C, and even beyond C. Let's keep the object here first, beyond C. If we take the uppermost point, then I can choose these two divergent rays passing through the center of curvature and another parallel to the principal axis. Both of these, after reflection, meet at this point. I could have also chosen another ray passing through the focus, and even that would have passed through this point. But I don't need this, as 2 points are enough. So, this point is the real image of the uppermost point as the reflected rays actually meet. Now, coming to the lowermost point, the ray passing through the center of curvature and parallel to the principal axis are both coincident, and this image will be real, inverted, and is diminished in size or smaller in size than the object. Now, if he stands on the center of curvature using the same rays, the image will also be real, inverted, but of the same size. Also, even the image is formed exactly at the center of curvature. If he stands between C and F, then the image is formed beyond C and is bigger or enlarged when compared to the object. Now from here, things start to get a little bit more interesting. If he stands at F and use the two regular rays, you will notice that the reflected rays are parallel to each other. Now, what's the property of parallel rays? Do they ever meet? Well, definitely not. So we say that these lines probably meet at an undefined point, which is at an infinite distance. Also, following the direction, one can say that this image will also be real, inverted, but much bigger or highly enlarged compared to the object. Now let's move the object a little bit more closer to the mirror. The only difference between this and the previous case is that the reflected rays are diverging and moving away from each other. But then, if you can extend these rays backwards, you will notice that these rays appear to come from a point. Thus, the image of this point is virtual, and therefore the image of Mr. O is virtual, but it is also erect, that is, not inverted, and it is enlarged in size. One last case is when, say, Mr. O is standing really far away from the mirror, that is, at infinity. In such a case, just imagine, do you expect him to be able to see his image? Well, that's exactly what happens. Since he is standing really far away, we assume parallel rays coming from him and hitting the mirror. All these rays meet at the focus, and this is the image for the object at infinity. It is real, inverted, and clearly highly diminished in size. So what have we learned in this video? We have seen the image formation in concave mirrors at different places. So until next time, happy learning!